Praise the Lord. Hello everybody. Welcome you all to this second session on the 13th chapter of your second PUC syllabus, probability. Dear students, in this session, we are going to deal the 5-marker question from this chapter, which you are going to get in your final year examination. And one more thing is, usually you have one 5-marker question from this chapter, and that would be most of in the 48th question in part D. Okay, part D is of 5-marker part. In that part, the last question, you are going to get 10 questions for 5 marks, out of which you have to answer any 6. But this would be the last question, and the question number would be the question number 48. Is it right? Fine. One more main instruction of this 5-marker is, dear students, you are not going to get the regular 5-marker question from this chapter, probability. Because of this COVID-19 reduced syllabus, the regular 5-marker question which has been asked from this chapter is being involved in the deleted portions. So you are going to get the new questions which have been framed for 5 marks. And most of you might have seen the design of the question paper which has been published by the PU board. In there, they have prescribed 5 of the most expected questions which can be asked from this chapter for 5 marks. And we are going to deal those questions in this session. I hope you enjoy this session. And my sincere advice is, kindly think about the question, because these questions are very easy for you if you can use your logical thinking and critical analysis. If you can think the problem and analyze it, these are very easy questions out of the other 5-marker questions. Okay, I'm not going to waste much of my time with my instructions, and I will directly go on to the topic, which would be the first question on probability chapter for 5 marks. So this is the first question, dear students. I'm going to read the question for you. A die is thrown. Okay, hope you have seen what a die is. I'm going to show you once again. A die is thrown. If E is the event, what is the event E? The number appearing is a multiple of 3. Okay, and F be the event, the number appearing is even. Okay, then find whether E and F are independent events. Okay, so this is the first question which has been asked, which has been proposed as one of the probable question from this chapter for 5 marks. So dear students, you might have seen the dice which contains, we know it, the sample space of when a die is thrown once would be, when you throw the die once, the sample space would be the 6 numbers, which is 1, 2, 3, 4, 5, and 6. Okay, so these are the 6 possible options when a die is thrown. Okay, therefore, I'm going to write the number of elements in the sample space is 6. Okay, I hope you have no doubts regarding the possible outcomes when a die is thrown. Okay, just for your example, I've taken a different colors of dice, but rather all are actually one and the same. Okay, now my next part of the question is, look here, I have to frame the events E and F. Now what is the event E? Please be careful. E is the event. The number appearing is a multiple of 3. Okay, so let me write the event E as number is a multiple of 3. Okay, what is the event? Number 3. Event E is the number which is a multiple of 3. Okay, so which are the numbers which are multiples of 3? Let me write the set here. Now you can see here, which are the multiples of 3 here? Only the number 3 and 6 are the multiples of 3. Okay, therefore I can write the number of elements of the event E is, clearly it is 2. Okay, next I'm going to frame the event F. according to his whatever he has given. The number appearing is even. Okay, so you can say probability of number is even. Okay, so I've taken an event E. I've taken an event E, which is a multiple of 3, and an event F, which is an even number. Therefore, what is my event F? Tell me the elements. Which are the even numbers here? We all know, we are very familiar with this. The even numbers are 2, 4, and 6. So let me write the numbers here as 2, 4, and 6. Therefore, the number of elements in the event F is nothing but 3. Isn't it? Very easy concept here. Okay, students. So once my E and F are ready, I'm going to consider what is E intersection F. Okay, a very important thing, because my main intention is to find whether E and F are independent. So how do I find the events E and F are independent? I've already given you the definition while I was dealing the 1-marker questions. E and F are independent if probability of E intersection F is P of E into P of F. Let us check. Now E intersection F is, you can see here, in E you have 3 and 6. In F you have 2, 4, and 6. So the common element in both E and F is 6, isn't it? Therefore, the number of elements in E intersection F would be 1. Okay, so with my given data, I'm going to prove the independence, whether they are independent or not. Okay, how I'm going to prove independent? Therefore, first let me find probability of an event E intersection F. So we all know probability of any event is the number of favorable number of outcomes. So number of elements in E intersection F divided by number of elements in the sample space. So this is nothing but E intersection F, you have one element, divided by number of elements in the sample space is 1 by 6. Okay, let me take this as equation 1. Okay, now similarly, let me find probability of E. Okay, so P of E would be, as previously, it is N of E, number of elements in the event E divided by number of elements in the sample space. This is nothing but, what is N of E? It is nothing but 2 divided by N of X is 6. That is nothing but 2 ones are and 2 threes are. Okay, next let me find out the probability of an event F. So this is nothing but the number of elements in the event F divided by the number of events in the sample space. So this is nothing but, in F you have 3 elements divided by total elements in the sample space is 6. So that is nothing but 3 ones are and 3 twos are. Okay, so I already have P of E intersection F. Let me consider what P of E, that is probability of E into probability of F. So this is nothing but, it is 1 by 3 into 1 by 2. Okay, so if you multiply, you get 1 into 1 is 1 and 3 into 2 is 6. Let me frame this equation as equation 2. Okay, now we are almost completed the process. We can see from equation 1 and 2, both probability of E intersection F is same as probability of E into probability of F. Therefore, we say events E and F are independent. Dear students, these are 5-marker question. Please make sure your conclusion is very clear. Okay, so I'm going to say from equations 1 and 2, we have, what do we have? Probability of E, probability of E intersection F is nothing but probability of E into probability of F. Okay, which is actually nothing but 1 by 6. Therefore, the events E and F are independent. Is it clear? So this is the conclusion for this question, and this will end the complete solution for the given question. Dear students, so this is the final result for this question. You can see here, this is a very easy question. If you can practice this once or twice, you can easily get 5 marks. If suppose this question is asked this year, particularly for the year March, or your exam is in May, so May 2021. Okay, in 2021 May exam, if this question is asked, you can easily get 5 marks, provided if you can work out this proper question neatly. Okay, right. Shall we move on to the next question? Dear students, my next question goes like this. Given two independent events A and B, such that P of A, that is probability of A is 0.3 and probability of B is 0.6. Find probability of A and B, probability of A or B, probability of A and not B. Fourth one is probability of neither A nor B. Okay, so with this question, we're going to frame whatever we want. So look here, before going on to proceeding on to the solution, always write the data. So the data given is, he has given P of A is equal to 0.3 and P of B he has given as 0.6. Okay, and one more thing is, kindly make sure your point is visible, otherwise it will look like 3 and 6. Okay, also A and B are independent events. Okay, A and B are, what do you mean by independent events? Any idea? We have already dealt in 1 markers, and just previously we have seen, yeah, because he has given two independent events A and B. Whenever A and B are independents, therefore probability of A intersection B will be P of A into P of B. That is probability of A into probability of B. Is it clear? So now with this, let me consider the first case. What we want? We want probability of A and B. Okay. Now, while explaining the condition or the definitions of probability, I've already told you, whenever you come across probability of A and B, it is always probability of A intersection B. Remember, okay? Probability of A and means intersection, or means union. Okay. Now, before we proceed this, let me consider this given data as equation 1. Okay. Now, this is nothing but, I want P of A intersection B. From equation 1, I can write P of A intersection B is P of A into P of B. You can write, the reason is using equation 1. Okay, because equation 1 is nothing but the given data. Okay, therefore this is nothing but, what is P of A? You can see here, P of A is nothing but 0.3 into P of B is nothing but 0.6. Okay, so this would be nothing but 0.3 into 0.6. You can use your calculators, you would have 0.18. Okay, so this is the answer for probability of A and B. So the second thing I am supposed to find is, what is the second thing I have to find? I have to find probability of A or B. Okay, so this is nothing but, as I already told you, whenever you say or, this is nothing but A union B. Okay, I want probability of A union B. Now, what is probability of A union B? I've already told you the formula of probability of A union B is probability of A plus probability of B minus probability of A intersection B. Okay, so this is nothing but, I already have all these values. P of A is 0.3 plus B of B is 0.6 minus P of A intersection B. Just now we have found out it is 0.18. Okay, so this is nothing but, you can use your calculators. 0.3 plus 0.6 is 0.9 and 0.9 minus 0.18 would give you 0.72. Okay, so this is the required answer for this condition, and I'm going on to the third condition. So what is the third condition I want? The third condition is probability of A and not B. Okay, remember, you have to use the condition probability of A and not B. Okay, I'm going to give you a clear idea of what actually is this probability of A and not B is. If you consider this set as A and set as B. Okay, this is the part which I want A and not B. So this actually is nothing but A minus B. So how do you get A minus B? In the entire set A, if I take away the intersection, I'm going to get A minus B, isn't it? So the same thing I'm going to do here. So the probability of A and not B is nothing but probability of A minus B. Okay, and this is nothing but you might have seen the in the formulas, probability of A minus B is nothing but probability of A, as I told you, the entire A minus probability of the intersection part, A intersection B. Okay, so in the entire A, if you take away the intersection part, I'm going to get A minus B, right? So this is nothing but P of A is already, I know the value, it is 0.3 minus A intersection B is nothing but 0.18. Okay, so this is nothing but 0.12. Okay, so you can use your calculators because it's it's very simple ones. If you're only confused, you can use your calculators. Otherwise, I hope you are capable enough to calculate without using the calculators, right? So I'm moving on to the last condition. And one more note before I'm moving on to the last condition. In your probable questions, you might see there, they've just asked you only the three conditions, that is P of A and B, A or B, A and not B. But in your textbook, you have even the fourth condition. So I'm going to solve even the fourth condition for you. In case they ask you for the examination, you should be able to solve this. So the fourth condition I want is probability of, you can see there, neither A nor B. Okay, probability of neither A nor B means, you can see here, you should either have neither A nor B. This would always be equal to, actually neither A nor B is nothing but probability of complement of the union. Okay, so it is A union B complement. Okay, your complement of the union is the neither case. Okay, probability of A nor B is actually always 1 minus probability of either A or B. Okay, either A or B. Always remember this. Probability of neither and probability of either are complementing each other. Okay, so probability of neither A nor B is 1 minus probability of either A or B. Okay, please see the difference between neither and neither nor to either and or. Okay, so this is nothing but 1 minus probability of either A or B means probability of or. So it is A union B, right? So this is nothing but 1 minus probability of A union B, we've already found out as 0.72. Okay, so this is nothing but, if you can subtract it, 1 minus 0.72 will give you 0.28, and that will conclude the complete solution for the given question. If you can solve this question and if it is asked in the examination, I hope you can easily get 5 marks, because these are easy questions compared to your determinant and matrices questions. Because in determinant and matrices, there is a lot of work to be done to get 5 marks, but these are easy questions compared to them. Okay, fine. Hope you have understood this question, and I'm moving on to the third question. So the third question we have here is probability of solving specific problem independently by A and B are 1 by 2 and 1 by 3 respectively. If both try to solve the problem independently, find the probability that the problem is solved. That is the first case. Exactly one of them solves the problem. Okay. Now let us analyze the question. There is a one particular problem. Don't worry what the problem is. There are two persons, A and B. They are trying to solve the problem separately. That is independently. Just underline the word independently. Now the probability of A solving the problem is 1 by 2. Probability of B solving the problem is 1 by 3. Okay. Now the question is, they both are trying it independently. I have to find out what is the probability the problem will be solved. Next one is exactly one of them solves the problem. Okay. So before proceeding with the solution, let us write down the data. So the data given here is, let us write, okay, A solves A. If you take an event A solves the problem, if A solves the problem, then probability of A solving the problem is actually you have 1 by 2. Okay, this will imply probability of A dash. A dash means A not solving a problem. Okay, the probability of he solving the problem is half, means the probability of E not solving is half. Okay, similarly, if B solves the problem, okay, if B solves the problem, okay, then probability of B would be 1 by 3. You can see here, he has given probability is 1 by 3. This will give me probability of B not solving the problem would be 1 minus 1 by 3. That would be nothing but 2 by 3. Okay, so probability of solving is given, probability of not solving is always 1 minus the event happening. Okay, now this is clear. Now I'm going to take the first condition. The condition is, okay, probability of problem is solved. Probability of problem is solved. Remember, the problem will be solved when either A is successful or B is successful. Is it not? That means even if only A is able to solve it, the problem will be solved. Only if B will be able to solve it, the problem will be solved. Or if both are able to solve it, then the problem will be solved. So you have to consider 3 cases. Instead of that, we would take the other option by taking this. The probability of problem is solved is nothing but 1 minus probability of problem is not solved. Okay. 1 minus probability of problem is not solved. Okay, so this is nothing but 1 minus, so probability of, when do you find the problem is not solved? It would be not solved when either A also is not able to solve it and B also is not able to solve it. Remember, A dash means A cannot solve it, B dash means B complement. Actually it is complement. B also cannot solve it. So this is nothing but 1 minus, remember, he has told you they are independent events. So because they are independent events, probability of A dash into B dash will be probability of A dash into probability of B dash. Okay, very simple. Try to analyze the question. So this is nothing but 1 minus P of A dash is nothing but 1 by 2 and P of B dash is nothing but 2 by 3. Okay, so this is nothing but 1 minus 2 and 2 gets cancels. You will get 1 minus 1 by 3. That is nothing but 2 by 3. Remember, so the probability of the problem being solved is 2 divided by 3. Okay, now the second, I'm moving on to the second case. What is the second case? Probability of exactly one of them solves the problem. Isn't it? So the second case, what I want is probability of exactly one of them solves the problem. What do you mean by one of them solves the problem? That means probability of, let me say, A solves, okay, and B fails. Okay, this is probability of A solves and B fails plus probability of A fails and B solves. Okay, because the question he is asking is only one of them should solve. That means there are 2 possibilities. One is A will solve and B fails. The other one is A will fail and B solves. Okay, so this is nothing but, remember, it is AND case. So probability of A solves means I will take A directly and B is failing, so I will take complement of B solving. Okay, similarly, plus probability as here in the second case is A is failing but B is solving the question. Okay, so this is nothing but, you can write probability of A into probability of B dash plus probability of A dash into probability of B. I'm splitting it because what is the reason? Because A and B are independent events. Okay, write down the condition. because A and B are independent events. Is it clear? So once the condition is already given in detail, I will going to use it. This is nothing but all the values are already there. P of A is nothing but 1 by 2. P of B dash, you can see there, P of B dash is nothing but 2 divided by 3. Okay, plus P of A dash is again 1 by 2 into P of B. What is P of B? P of B is 1 by 3. Okay, so this is nothing but, for simplification purpose, I will multiply directly. 1 into 2 is 2, 2 3s are 6, plus 1 into 1 is 1, divided by 2 3s are 6. Okay, so if you take the LCM, this is nothing but 1, the denominator is same, which is 6. You will get 2 plus 1. This is nothing but 3 by 6, and that is nothing but 3 ones and 3 twos are. So the probability of exactly one of them solving the problem is 1 by 2. Okay. To solve the problem, it doesn't take much of your time. Only thing is you have to analyze the question before solving it. Okay. Right? I hope I've given you a clear idea of what the analysis of the part is. Once the question is analyzed properly, the solving point is very simple. Okay, you can easily solve because these are the regular formulas which we have already seen even from first PUC mathematics. Okay, because even in first PUC, the last chapter we have, that is the 16th chapter in first PUC mathematics, is probability. And same thing here, the last chapter in second PUC maths is also probability. And remember, this is the continuation of what we left in the first PUC, right? So this will conclude the complete solution for this question, and we shall move on to the fourth one of this type. So the fourth question we have is, two balls are drawn at random with replacement. Underline the word with replacement. Okay, from a box containing 10 black balls and 8 red balls. Okay, there is a box which has 10 black balls and 8 red balls, and you are picking 2 balls at a time. That is with replacement. Remember, once you take a ball, when you are taking another ball, you are replacing it back. Please understand the question. Find the probability that both balls are red. Second case is, first ball is black, the second is red. Third one is, one of them is black, the other one is red. Okay, so remember, let me say B is, okay, black ball. How many black balls we have? We have totally 10. Okay, and R is nothing but red ball. Okay, how many total red balls are there? You can see here, there are 8 balls which are red. Okay, so total number of balls. Total number of balls is 10 plus 8, that is nothing but 18. Okay, now therefore remember, probability of picking a black ball. So probability of picking a black ball is, out of 18 balls, if there are 10 balls which are black, so probability of a black ball is 10 by 18, which is nothing but 2 5s are and 2 9s are. Okay, similarly, probability of picking a red ball is nothing but, out of 18 balls, there are 8 red balls. So that is nothing but 2 4s are 8 and 2 9s are 18. Okay, so this is basic results, P of B and P of R. Okay, now remember, therefore, the first case is probability of both are red. Okay, what is the probability of both are red? So this is nothing but probability of red and red. Okay, so I want red in the first pick also and red in the second pick also. Okay, so this is nothing but probability of R intersection R. Okay, because and means intersection. Now remember, they are independent events because each ball has the equal likely to be selected. So therefore they are independent events here. Therefore P of R intersection R would be probability of R into probability of R. Why I say, and one more thing is, remember, with replacement. Now look here, in the first case, when if I have to select a red ball, you can see here, this is the probability of selecting a red ball, 4 by 9. Okay, now remember, because I'm replacing the ball back, are you following? I'm replacing a ball back means ಈಗ ಬಾಲ್ ಬಾಕ್ಸ್ ಇಂದ ಒಂದು ಬಾಲ್ ತೆಗೆದ ನಂತರ ನೆಕ್ಸ್ಟ್ ಸೆಲೆಕ್ಷನ್ ಅಲ್ಲಿ ತೆಗಿಯೋಕಿನ ಮುಂಚೆ ನಾವು ಮತ್ತೆ ವಾಪಸ್ ಆ ಬಾಲ್ನ ಹಾಕ್ಬಿಡ್ತೀವಿ. ಅದನ್ನೇ ನಾವು ವಿತ್ ರೀಪ್ಲೇಸ್ಮೆಂಟ್ ಅಂತೀವಿ. ಇಸ್ ಇಟ್ ಕ್ಲಿಯರ್? ಸೊ ಐ ಆಮ್ ರಿಪ್ಲೇಸಿಂಗ್ ಬ್ಯಾಕ್ ದ ಬಾಲ್. ಸೊ ದಟ್ ಮೀನ್ಸ್ ಈವನ್ ಇನ್ ದ ಸೆಕೆಂಡ್ ಪಿಕ್ ದ ಪ್ರಾಬಬಿಲಿಟಿ ಆಫ್ ಗೆಟಿಂಗ್ ಅ ರೆಡ್ ಬಾಲ್ ಇಸ್ 4 out of 9. Is it clear? A very simple solution. So this is nothing but you can multiply 4 4s are, it is 16 divided by 9 9s are 81. So this is the first condition of probability of getting both are red balls. Okay. Now moving on to the second condition, what we are supposed to find out is probability of, remember, first is black. Okay. Let me say probability of black and, okay, red. Means my first ball should be black and the second ball should be red. So this is nothing but probability of, as I told you, you will get B and R. Okay, this is nothing but probability of B and means intersection R. Okay, is it clear? So this is nothing but what is probability of B separately. Because they are independent events, I'm going to take probability of B and R is P of B into P of R. Okay, so this is nothing but P of B, you can see here, it is 5 by 9 into P of R. Probability of a red ball is 4 by 9. Remember, in the when you are selecting a black ball in the first case, the probability of getting a black ball is 5 by 9. When the second time, in the second pick, if I want red ball, as we have already replacing the balls back, it is 4 by 9, right? So this is nothing but 4 5s are, it is 20 divided by 9 9s are 81. Okay, so let me consider this as the first case and this as the second case. Okay, please be very careful. These are easy questions. Only thing is you have to understand or analyze the question neatly. Okay, so now the third case is probability of one of them is black. Are you following? Probability of one of them is black and the other one is red. Okay, you can say one black and one red. Okay, I want the probability of one black and one red. Okay, so this is same as I can write probability of, I will take red and black. Are you following? Let me say in the first pick I will get red and the second pick I'll get black. That means I'm getting one color in one pick. Okay, plus, or there is another way around. I can either get probability of black ball in the first pick and red ball in the second pick. Okay, so once this is clear, I'm going to easily get the answer. So this is nothing but P of R into P of B plus P of B into P of R. Okay, so this is nothing but all the values are here. P of R is nothing but 4 by 9 into P of B is nothing but 5 by 9. Okay, plus once again P of B, probability of black ball is 5 by 9, probability of red ball is 4 by 9. So this is nothing but 4 5s are, this is 20 by 9 9s are 81, plus once again 4 5s are, it is 20 by 9 9s are 81. So this is nothing but if you add, the denominator is same, which is nothing but 81, and 20 plus 20 will give me 40, and this is the required solution for the above given question. Okay, so dear, remember students, before solving these type of questions, you should always understand the question neatly, and particularly whenever you come across these kind of questions, check this word whether the question is with replacement or without replacement. Okay, whenever you say the replacement are allowed, means with replacement means picking any ball on the first attempt and second attempt, both are same because you are putting the ball back. In case if you are, let me say, if the replacement is not allowed, if the replacement is not allowed, then picking a black ball in the first case would be 10 out of 18. Okay. In case if the repetition is not, the replacement is not allowed, for the second case, once you pick a black ball, it is kept aside. Okay, remember. So in that case, probability of picking a black ball, given that the first ball is black, would be 9 out of 17. Remember, because there would only be 17 balls, out of which only 9 are black. That would be the case if the question is without replacement. Don't worry, they are not going to change this question without replacement. So be comfortable with this question however it is, and practice this question, and if it is asked in the examination, you can easily get 5 marks. Dear students, I hope this question is easy also. Remember, I have one more note before going on to the next question. This question has been asked as the second, has been asked in the second model question paper, which the PU board has released for 5 marks. Okay, there are 2 model question papers which has been released on the basis of reduced syllabus. So in the second model question paper, you can find this question for 5 marks in the 48th question. Okay, and in the first model question paper, the question which we solved, the third question, that is the problem question. Okay, the problem which is solved, A and B trying the problem separately. This question has been asked in the model question paper 1. Okay, so there are 2 model question papers given for you for this reduced syllabus by the board, and in both in those papers, these are the 2 questions which has already been asked. The other 3 questions are the probable questions. Okay, so we have already solved 4 questions, and we are moving on to the one last question for the session. Okay, are you ready for it? Okay, students, the 5th question we have is: a fair coin and an unbiased die are tossed, okay, are thrown. Let A be the event head appears on the coin and B be the event 3 on the die. Okay, check whether A and B are independent events. Okay, there are 2 events happening. Remember, 2 simultaneous things are happening. It may be simultaneously you are doing it, or it is just like, see, I have a coin and a die. I can just throw it. So you can see here, on the coin I got a tail, and on the die I got a number 4. Okay, if you can keep on trying it in different times, you can get another option. So you got head with 4. Okay, you can try it and you may get another option with C. You get tail with 2. So with this case, now I want to find out with the given conditions whether the events A and B are independent. Okay, so let us first, since it is all about a coin and a die. Okay, so for our reference, I'm keeping a coin and a die along with writing the sample space, because it would be easy for us to write the sample space. Okay, so in the sample space, first a coin is tossed and a die. Okay, so let me say when a coin is tossed, you can get head. So along with that, when a die is thrown, you may get 1 as a number. Okay, in the same way, with head I may get 2. Along with head I may get the number 3. With head I may get the number 4. With head I may get number 5. And with head I may get a number 6. Okay, similarly, the same case, with tail I'll get 1. So T2, T3, T4, T5 and T6. Okay, so these are the total elements which is allowed in the sample space. Therefore, I'll write number of element in the sample space is 12. Is it clear? So the 12 options are available now. Now let us frame the events A and B according to what he has given. Now what is the event A? What is the event A? Be the event head appears on the coin. So let me say event A is head appears on the coin. Okay, therefore write the elements of A. This is nothing but what is the, so which are the possible items with head? So the first 6 ones, that is nothing but you have H1, H2, H3, H4, H5 and H6. So this is the event A. Therefore, you can write the number of elements in the event A is 6. Is it clear? Now let us frame the event B. Now what is the event B? Event B is 3 on the die. Okay, number 3 on the dice. Okay, so the event B is number 3 on the die. Therefore, which are the possible options? 3. Which are the possible options which you have 3? Only these two options. That means with head I may get 3, or with tail I may get 3. Okay. Therefore, the number of elements in the event B is simply 2. Is it clear? Now, further, let me get A intersection B. The event A intersection B. So I have event A as H1 to H6 and event B as H3 T3. You can see here the common element in both of them is only H3. Okay. Therefore, the number of element in A intersection B is simply 1. Okay. This question is similar to the first question we solved in this session. Okay. Therefore, first let me find probability of A intersection B. So probability of A intersection B is number of elements in A intersection B divided by number of elements in the sample space. That is favorable number of outcomes by total number of outcomes. So this is nothing but, so n of A intersection B is 1 divided by n of S is actually 12. Is it clear? So let me consider this as equation 1. Okay. Let us calculate P of A and P of B separately, because remember I have to check whether A and B are independent events. Now I know the condition to prove they are independent events. So before that, P of A is n of A divided by n of S. This is nothing but, you can see here, n of A is 6, n of S is 12. This is nothing but 6 ones are and 6 twos are. Okay. Similarly, P of B would be n of B divided by n of S. This is nothing but, what is n of B? You can see here 2 divided by 12. This is nothing but 2 ones are and 2 sixes are. Okay. Therefore, let me consider, okay, P of A into P of B. So this is nothing but, it is 1 by 2 into 1 by 6. So this is nothing but 1 divided by 2 into 6 is 12. Okay. Now you can compare the equations 1 and 2. So you can write from equations 1 and 2. This is the conclusion part of it. Please be careful. You have to write the conclusion. Otherwise, you're going to miss 1 mark. So from equations 1 and 2, we get, or we have, you can write, what do you have? You have probability of A intersection B is nothing but probability of A into probability of B, which is nothing but 1 divided by 12. Okay. Therefore, you can write hence A and B are independent events. A and B are independent events. Okay. And that will conclude the complete solution for the given question, which is the 5th question of this type. So dear students, you can see that these questions are really easy for you if you can understand the question, and particularly in these kind of questions, if you can frame the sample space and write the events, you can easily get 5 marks if these questions are asked in your examination. I told you these questions have not been asked even once in your previous year's examination, because the original 5 marker question were not asked in this type, because that portion is coming falling along the deleted portions for the academic year 2020-2021. Okay, so they have framed 5 new questions, which are probably the questions which have to be asked for this year on the 48th question. Okay, dear students, kindly practice these 5 questions. There are more chances for 1 question to be asked out of these 5. Okay, I hope you have understood this. You have enjoyed this chapter also, because this is like playing games. Okay, kindly work it out and you will be able to solve it in the examination. ಪ್ರೀತಿಯ ವಿದ್ಯಾರ್ಥಿಗಳೇ, ನಮ್ಮ ಇಂದಿನ ಸೆಷನ್ನಲ್ಲಿ ಪ್ರೊಬಾಬಿಲಿಟಿ ಚಾಪ್ಟರಲ್ಲಿ ಕೇಳಬಹುದಾದಂಥ 5 ಮಾರ್ಕರ್ ಕ್ವೆಶ್ಚನ್ಸು 5 ಪ್ರಾಬಬಲ್ ಕ್ವೆಶ್ಚನ್ಸ್. ಇದು ನೆನಪಿರಲಿ, ನಿಮ್ಮ ಹಳೆಯ ವರ್ಷಗಳಲ್ಲಿ ಕೇಳ್ತಾ ಇದ್ದಂಥ 5 ಮಾರ್ಕರ್ಸ್ ಇವಲ್ಲ. ಅಲ್ಲಿ ಆ ಪೋರ್ಷನ್ಸು ಡಿಲೀಟೆಡ್ ಸಿಲೆಬಸ್ಸಲ್ಲಿ ಇರೋದ್ರಿಂದ ನಿಮಗೆ ಹೊಸದಾಗಿ ಒಂದು ಪ್ರಾಬಬಲ್ ಆಗಿ ಬಹುಶಃ ಇದರಲ್ಲಿ ಈಗ ಸಾಲ್ವ್ ಮಾಡಿದಂತಹ 5 ಕ್ವೆಶ್ಚನಲ್ಲಿ ಯಾವುದಾದ್ರೂ ಒಂದು ಖಂಡಿತವಾಗ್ಲೂ ನಿಮಗೆ ಎಕ್ಸಾಮ್ಗೆ ಬರ್ಬೋದು. 48ನೇ ಕ್ವೆಶ್ಚನ್ ಇರುತ್ತೆ. ಸೊ ನೀವು 10 ಕ್ವೆಶ್ಚನಲ್ಲಿ 5 ಮಾರ್ಕ್ಸ್ ಯಾವುದಾದ್ರೂ 6 ಅಟೆಂಪ್ಟ್ ಮಾಡಬೇಕಾಗಿರೋದ್ರಿಂದ ನನ್ನ ಪ್ರಕಾರ ನಿಮಗೆ ಈ ಕ್ವೆಶ್ಚನ್ನ ನೀವು ಒಂದು ಚಾಯ್ಸ್ ಆಗಿ ತಗೋಬೋದು. ಓಕೆ, ಇದನ್ನು ನೀವು ಅಟೆಂಪ್ಟ್ ಮಾಡಿ ನೀವು ನೀಟಾಗಿ ಈ 5 ಕ್ವೆಶ್ಚನ್ನ 1-2 ಸರಿ ಅಥವಾ 1-2-3 ಸರಿ ಬರೆದು ಪ್ರಾಕ್ಟೀಸ್ ಮಾಡಿದ್ರೆ ಸುಲಭವಾಗಿ ನೀವು ಇದನ್ನು ಮಾಡ್ಬೋದು. ಮತ್ತು ಇದು ಇನ್ನೊಂದು ಏನಂತಂದರೆ, ನಾನು ಎಕ್ಸ್ಪ್ಲೇನ್ ಮಾಡೋಕ್ಕೆ ಸ್ವಲ್ಪ ಹೊತ್ತು ತಗೊಂಡಿರ್ಬೋದು, ಆದರೆ ನೀವು ಪ್ರಾಕ್ಟೀಸ್ ಮಾಡಿ 2ನೇ ಸರಿ ಬರೆಯುವಾಗ 5 ನಿಮಿಷಕ್ಕಿಂತ ಕಡಿಮೆನೇ ಈ ಸೊಲ್ಯೂಷನ್ನ ಬರೆದು ಮುಗಿಸ್ತೀರ. ಓಕೆ, ಆದ್ದರಿಂದ ದಯವಿಟ್ಟು ಪ್ರಾಕ್ಟೀಸ್ ಮಾಡಿ. ಆಗ ಈ ಕ್ವೆಶನ್ಸ್ನ ಎಕ್ಸಾಮಲ್ಲಿ ಕೊಟ್ಟರೆ ನೀವು ಆರಾಮಾಗಿ 5 ಮಾರ್ಕ್ಸ್ ತೊಗೋಬೋದು. ಎಷ್ಟೋ ಸ್ಟೂಡೆಂಟ್ಸು ಪ್ರಾಬಬಿಲಿಟಿ ಕೊನೆ ಚಾಪ್ಟರ್ ಆಗಿರೋದ್ರಿಂದ ಅದನ್ನು ಬಿಟ್ಟುಬಿಡ್ತಾರೆ. ಅವ್ರು ಬೇರೆ ಯಾವುದೋ ಕ್ವೆಶನ್ಸ್ ಟ್ರೈ ಮಾಡಿ ಅಲ್ಲಿ ಸ್ವಲ್ಪ ಕೆಲವು ಸರಿ ಬರಲಿಲ್ಲ ಅಂದರೆ ಮಾರ್ಕ್ಸ್ ಕಳ್ಕೊತಾರೆ. ನಿಮಗೆ ನಾನು ಹೇಳೋದೇನೆಂದರೆ, ಪ್ರಾಬಬಿಲಿಟಿ ತುಂಬ ಸುಲಭವಾದ ಚಾಪ್ಟರ್ ಆಗಿರೋದ್ರಿಂದ ದಯವಿಟ್ಟು ಒಂದ್ಸರಿ ನೋಡಿ. ಆಗ ನೀವು ಪ್ರಾಕ್ಟೀಸ್ ಮಾಡಿದ್ರೆ ನಿಮಗೆ ಅನಿಸುತ್ತೆ ಈ ಕ್ವೆಶ್ಚನ್ನ ಡೆಫಿನೆಟ್ಲಿ ನೀವು ಎಕ್ಸಾಮಲ್ಲಿ ಅಟೆಂಪ್ಟ್ ಮಾಡ್ಬೋದು ಅಂತ. ಓಕೆನಾ? ಓಕೆ ಸ್ಟೂಡೆಂಟ್ಸ್, ನೀವು ಈ ಒಂದು ಸೆಷನಲ್ಲಿ ಮಾಡಿದಂಥ 5 ಕ್ವೆಶನ್ಸ್ ನಿಮಗೆ ಅರ್ಥ ಆಗಿದೆ ಅಂತ ನಾನು ಭಾವಿಸ್ತೀನಿ. ದಯವಿಟ್ಟು ಈ ವಿಡಿಯೋ ನಿಮಗೆ ಇಷ್ಟ ಆಗಿದರೆ ನೀವು ಲೈಕ್ ಮಾಡ್ಬೋದು, ನಿಮ್ಮ ಫ್ರೆಂಡ್ಸ್ ಜೊತೆ ಶೇರ್ ಮಾಡಿ. ಅದು ನಮಗೆ ನಿಮ್ಮ ಕಡೆಯಿಂದ ಸಿಗುವಂಥ ಸಪೋರ್ಟ್ ಆಗುತ್ತೆ. ನೀವಿನ್ನೂ ನಮ್ಮ ಚಾನಲ್ನ ಸಬ್ಸ್ಕ್ರೈಬ್ ಮಾಡಿಲ್ಲ ಅಂತಂದರೆ ನೀವು ಸಬ್ಸ್ಕ್ರೈಬ್ ಮಾಡಿ ಆ್ಯಂಡ್ ನಮಗೆ ಸಪೋರ್ಟ್ ಮಾಡಿ. Kindly students, share these with your friends so that it would reach more students, because a lot of efforts has been going through in making these videos. Please make use of it so that you should score good marks in your main examination. Okay, the reason behind I making all these videos is to prove to you that mathematics is really not difficult subject to pass in your second PUC. Okay, ನೆನ್ಪಿಟ್ಕೊಳ್ಳಿ, ಸೆಕೆಂಡ್ PUC ಮ್ಯಾಥಮೆಟಿಕ್ಸಲ್ಲಿ ನೀವು ಮ್ಯಾಥಮೆಟಿಕ್ಸ್ನ ಫೇಲ್ ಆಗೋಕ್ಕೆ ಕಷ್ಟಪಡಬೇಕೇ ಹೊರತು ಪಾಸ್ ಆಗೋದಕ್ಕಲ್ಲ. ಮತ್ತೆ ಹೇಳ್ತಾ ಇದ್ದೀನಿ, ಸೆಕೆಂಡ್ PUC ಮ್ಯಾಥಮೆಟಿಕ್ಸಲ್ಲಿ ನೀವು ಫೇಲ್ ಆಗೋಕ್ಕೆ ಕಷ್ಟಪಡಬೇಕು, ಪಾಸ್ ಆಗೋದಕ್ಕಲ್ಲ. ಯಾಕೆಂದರೆ ಇರುವಂಥ ಸಮಯನ ಹೇಳಿದ ರೀತಿಯಲ್ಲಿ ನೀವು ನೀಟಾಗಿ ಫಾಲೋ ಮಾಡಿದ್ರೆ 35 ಮಾರ್ಕ್ಸ್ ಅಲ್ಲ, ನೀವು ಆರಾಮಾಗಿ ಯು ಕ್ಯಾನ್ ಸ್ಕೋರ್ ಮೋರ್ ದೆನ್ 60. ಓನ್ಲಿ ಥಿಂಗ್ ಇಸ್ ಯುವರ್ ಹಾರ್ಡ್ ವರ್ಕ್ ಆ್ಯಂಡ್ ಡೆಡಿಕೇಶನ್ ಈಸ್ ರಿಕ್ವೈರ್ಡ್ ಅಲಾಂಗ್ ವಿತ್ ಸ್ಮಾರ್ಟ್ ವರ್ಕ್. ಓಕೆ, ನೀಟಾಗಿ ಪಿಕ್ ಮಾಡಿ. ಸೊ ಈಗಲಿಂದನೇ ಸ್ವಲ್ಪ ಸಮಯ ಇದೆ ಎಕ್ಸಾಮ್ಗೆ, ಸೊ ಈಗಲಿಂದನೇ ಚೆನ್ನಾಗಿ ಓದ್ಕೊಂಡು ಬನ್ನಿ. ಆಗ ನಿಮಗೆ ಎಕ್ಸಾಮ್ ಟೈಮಲ್ಲಿ ನೀವು ಯಾವುದೇ ಭಯ ಇಲ್ಲದೆ ಅಟೆಂಪ್ಟ್ ಮಾಡೋಕ್ಕೆ ಸಾಧ್ಯ. ಓಕೆ, ಫೈನ್ ಸ್ಟೂಡೆಂಟ್ಸ್, ಹೋಪ್ ಯು ಹ್ಯಾವ್ ಎಂಜಾಯ್ಡ್ ದಿಸ್ ಸೆಷನ್ ಆ್ಯಂಡ್ ಆಲ್ಸೋ ಲರ್ನ್ಡ್ ದಿಸ್ 5 ಮಾರ್ಕರ್ ಕ್ವೆಶ್ಚನ್. ಐ ಬಿಲೀವ್ ದಟ್ ಯು ವುಡ್ ಡೆಫಿನೆಟ್ಲಿ ಅಟೆಂಪ್ಟ್ ದಿಸ್ ಕ್ವೆಶ್ಚನ್ ಇನ್ ಯೋರ್ examination. Well, we'll meet again in another session with different topics. Until then, take care and bye.